Hi everybody, this is a walkthrough for the first rumor is released this week. I didn't do video for it, I was a bit busy. Anti-reverse engineering learned the technique used to buy malware author to bypass detection. This is a follow-up series of a couple of malware rooms by Tryhackme. So you can check the other one, the basic and advanced dynamic analysis. So let's start the room. Uh, Of course, there's a couple of software we'll use now. Come for debuggers for malware analysis. We'll use the Axis for DBG. Basically, we'll use this one. I think the 32 version. We're not using this to Ghidra. We used a couple of times, but for this room, it's mainly using this one. Anti-debug technique, of course, checking for the presence of debug. Of course, any malware start to detect. You guys, you can read. Of course, this room I'm following the labs. Detecting the lab's names of processes and things like that, tampering with debugger registry. So basic malware try to trick the system always using self-modified code. And then what's the question? What is the name of Windows API function used in common anti-debugging technique that detect if a debugger is running? Yeah, that's what is that. It's already here. So this was just an introduction. Sorry. Now we're starting. Suspend thread is a Windows API function that is used to pause the execution of the thread. What's better way to start debugging than not making the debugger work at all? That's what the tricks what usually malware will use. So let's run first of all our debugger, the 32. That's how it look. Let's open another one. Let's say suspend thread. Let's open suspend thread. Press F9. You can see these shortcuts are already here, so where they are. F9 basically is run. That's why they use this. So the starting point. Notice that will not become unresponsive. Hold on. Twice. Let's press it again twice. Run again. Now you can see the freezing. Because now the malware detect the packer and that thing. So we need to know task manager, our friend all days. Task manager. So it won't froze. So the malware now froze the debugger. Notice that will become unresponsive. You can confirm the suspension process. Now you can see our debugger is there. So of course our option here is we need to kill this process and task. And then what happened? Now this is the code as they stated that this software was using. The codes name below show how the malware works in, I'm not sure read this code, this language is Windows stuff. So for each thread we called enum window. Basically to each the malware is trying to see all the title of window open and and if it's C you can see and that's the value later on we change these zeros. Remember these zeros now, we'll need it later. So if Windows title debugger or dbg or something, it will change that value 0 to 1 and then basically um, freeze our system. The debugger is when the malware calls which suspend the thread of the debugger. So that's exactly why it froze. Now one of the tricks that malware analysts use is patching. Now let's go back to our debugger. Let's open that software again. Open recent. Open suspend thread. Now press F3 key to show the open dialog window. No, this is just he likes shortcuts. I think he's trying to teach us the shortcuts this room. Basically you just open file. F3 is open, so let's use mouse for laziness today. Then press F9 to jump. So you know the F9 is for jumping. Now we jump to F2, the starting point. Of course, F9 here. Let's run it, and then below, then right click in anywhere in the menu, then search for the current model. So let's search current model intermodular calls. Then let's search for the suspend thread of the suspend thread, that's this one, and then double click on it. So we'll come back there. You are now in the part of the code that called the suspend thread. That's a suspend thread. So that's what to skip this function, right click on the suspend thread line and select binary. This is the trick. What we do is binary and then fill with nope, no, like do nothing or something. Then don't change everything, just press OK. See what happened on value changed to 90. And nope, I think NOP stand for nothing. I'm not sure, I forgot what it stand for. So basically now when the script or the malware arrive to this place, do nothing. So basically we jump. Now you will see that memory location 0040 11B until this one, they all have all the news set to 90 and hex value or nope, you can see here. No operation, okay. If execution reaches this instruction, it will do nothing. That's exactly our trick. Now press F9, we can continue this F9, now run it. To continue execution, we'll see the debugger continue at the very end without crashing. Let's where's that thing? You can see now. You know, here you can see message you say debugger found with PID suspending, but really is not suspending anything, because basically now is jumping this place. It's not doing anything, the function does not suspend. So now this is good. However, if you try debugging again, you will discover it will start crashing again. Of course, because now if we close again, our work is not saved. So that's why we need to export and export our patch. To do that, where is that patch again? Stop a debugger by pressing Alt F2. Alt F2. Oh, see, they hate this. When you do like that, it doesn't work. My computer now is the one that using Alt F2. To stop debugger is this one. Hold on. Alt F2. This one. Alt F2. Stop debugger. And go through the patching steps in the previous section, but do not do last step. So basically we can open again the recent file, the suspend thread. We do this, but we don't do the last one. So we can we open run it, so F9, then if you follow the same thing, search for current model and call suspend thread. Where is suspend thread? Then we find it. Then what we do, the main window showing okay, click on it, right click on it. Okay, we right click on it and then binary, then fill with knob, press OK. We done, and they said don't do the last step. Last step is F9. So that's for now. We can stop here. So we know we do the export. So stopping and open the patch you want. Once the patch you want are in place, on the top bar go to view patch file. View patch file. Where is the patch file? You can see 6 entries. This one. 1 2 3 4 5 6. This refers to the 6 memory location that we have set to know. Oh, that's 1 2 3 4 5 6. This memories, okay. And then we say click export button, so you can, your patch overlap with the relocation region. This can cause your, why is saying press yes to continue. We can save it my patch. Okay, by export. Stop. Okay, debug file again because debug has restarted. Our previous patch have now been erased. We can restore, so we can we close this. We're done with this. So now we can stop this. What is it? Alt F2. Alt F2. So basically this one close. So if you open a file again, open suspend thread, then we can go to our patch file, can import my patch, 6 spot applied, and then okay. Once imported, close the window and press F9. So this is F9, debugger, run F9, suspend thread. You notice that the previous patch are now reapplied. Where they are, how to find them? To be, so they should be when they said last time in memory is like what memory they've been applied to? 1AB. Call suspend thread. I'm losing nothing. Let me search for it. Search for, no, go to the expression. Let's see if it's really done, or I'm confused now what this room is talking about. 0 40 11AB. Let's go there. Oh yeah, you can see the patch was applied. Yeah, so it's correct. So okay, so that's cool. Now that's it. What is the Windows API function that enumerate windows on the screen so the malware can check the window name? We talk about this here. So this is this Windows. That's the one that you can Windows title. I think so. I'm learning this malware. I'm new on it, guys. So I'm trying my best to explain. What is the hex value of no trip? The hex value is this 90. Sorry. What is the instruction found at the memory location this, so we can just do go to expression memory 004011 CB, so we can write CB here. Let me go to that memory. That's the line, that's the instruction, that's line CB. So the question is add ESP at 8. So that's the answer. Let's go to next one. This one is VM detection. Of course, here is like the malware will detect if you open it or run it in the VM. So when the malware detect that you're on the VM, it change. So one thing is the malware will change the process. They know that you use VirtualBox, you using VMware, so it tests you there. Checking and installing software. Network fingerprinting because VMware the MAC address, checking machine resources, detecting peripheral, checking domain membership, and all of that. Some researchers have, okay, there's a lot of things you can do because you can read about it. What is the name of the identifiable process used by malware to check if the machine is running inside VirtualBox? The process of VirtualBox is this one, so it's already there in the room. So that's if they found it, malware to change. Sorry. What is the LIUI automatically assigned specific? This is the MAC address. Search the internet. You can find it here in VMware. All VMware they start with this. That's the what they call it, organization, the CompTIA exams, organization unified identifier or something. I think so. Yeah, I think that's why. Unified identifier. I still remember the days of CompTIA. And then use the task manager with process. Where is our friend? Task manager, where are you? What process? It's running an EC2. Uh, EC2. Now you can see that's it. This is already Amazon there. Amazon.ssm.agent.xe. That's the process that's running there. Then if we go to the next one, VMware detection by checking the temperature. Here's an example of VM detection technique. Check the machine temperature provided by the hardware. Windows temperature probe is the Windows management instrument VM. Okay, so that's what the malware do. May also return not supported. Okay, where is this? You have provided VM detection. So we have now with that malware VM detection. Let's run it. Proceeding with no malicious activities. Upon execution, a message window will appear. As you can see, the malware sensed it was running in the VM. It modified its behavior by containing a non-malicious activity. So it will do you think it's doing nothing wrong? Because it knows it's inside the VM. That's the code. I'm not familiar too much about it. You can try compiling and running the code in your physical machine to see how it changes. The output below show processing malicious activities, preventing temperature checking. As mentioned in the previous task, architecture check like checking the temperature can be challenging to prevent. Fortunately for us, there's still a way. For example, we use the nopes that we did before. By changing the memory here, there's an example. Let's try. Now we open a new one, which is number VM detection. The VM detection one we started. Okay, now we have that. So as usual, you can run it. F9, you get the starting point. That's 41A1. That's VM detection. You detect there. Press OK, and then what's it? And then he said, let's go to expression 004010 E0. What the hell is this? VM detection. Press OK, it will take you to this memory address. Press F2 to set a breakpoint. F2 is the breakpoint. I'm a bit still learning, and there's too many things. A breakpoint or something. Why my breakpoint is not the same as him? Oh no, I did a mistake. Press there, and then you put no, not here. Breakpoint should be there. F2 here, and then press F9. We can run it here. Press F9 once to alt execution here. Okay. Right now we are at the memory location 10E0. This one. The block of instruction from this location up until F8. This one. He said is a C code, that one. So I'm not really see the code. Guys, I'm not sure exactly here what's the story here. I'm trying to I'm still new in this malware things, but you see that's the part of the code. To help you visualize this, we add a comment. So this there, you return. So what the, okay, I assume it's whatever it is. I'm not sure. Sorry guys, previously discussed, this function will fail because we run in the VM. After executing the function, we write the value 0. Okay, that's the memory location is E18. This one. The one marked you returned. So this one. Okay. In this is a screenshot of it. Press F8 few times to step through the code until you reach FD. F8, F8. F8 is that one. This until we arrive to FD. Where is FD? FD is in the bottom. Okay, we are here. Then we arrive now to EPB18. So yes. Here we can see that the value of EPB18 or written is being compromised to 0. Oh, you can see there's a 0 here. So we have 0 here. So the idea to change this 0 to 1. To do this, right click in EP18 and then follow in dump and then EP18, and you can see that's the memory here. It's a F08, it's this line here. So F08, where is this F08? This one. 019 FF, yeah. F08, this one. This one. So now we need to change the the click on it, make it 1. So now we change it to 1. That's it. You know, this value came from this. Turn your attention back to the main window, CPU tab, and press F8. What F8 do? I forgot F8. Step over. Step over. A few times you will notice that the code will not exit anymore, and it is skipped execution from 1101 to 110A. Let's try it. Yeah, it jumped. You see, it jumps straight because now that we change that one to 1, so it jump. Okay, we manipulated the bits of the memory location directly to influence the flow of the program. This method is helpful in many other ways, like for example, you could change the value that will be passed to the function before you execute that function. Okay, however, the program will not crash if you continue running the program. The program was supposed to exit at the previous function, but we have introduced the bug since we intentionally skipped this. Don't worry, this always happens when messing around. Let's say that we want to skip everything and jump to this part of the code right here. Print. This will be instruction 32. Okay. The great thing about debug is that we can change every value related to the program. We can change the value of the memory. Continue from the last step on the register panel on the right on your screen. Look for the one that say IP. Right of the screen, IP. IP, yeah. Right click the value and select modify value. Okay, enter 401134. Press OK. Oh, we jump into 34 now. Now when we press F8, step over, so is this button, you will notice that will jump directly to the instruction. The marker, it's in 34 it was, so you jump. I don't get this part exactly what's happening. Press F9, so run. Processing ammunition activities. Okay, so it's there. Good job with the boot step. You successfully prevented the malware from detecting that is only in the VM. I don't lie to you guys. I'm just I'm a bit I need to learn more about this. I can follow exactly the instruction, but I'm getting confused here. In any case, let's see if we can answer the question. In the C code in snippet, what is the full WQA query used to get the temperature probe class? Um, query. The query should be like select something like MySQL. I remember this. I already did this room, so it's not like I'm lying at you. What the hell? Now I'm like I'm blind. I don't see. HR. Oh, this is W query. From select everything from this. It should be this one. No. Sometimes Tryhackme just confuse me. Well, don't tell me it's just this one. Okay, so is that one? What register hold the memory address that tell the debugger what instruction is next? This one is this one, the register, the EIP. This room is a bit work. Before you return is compared to 0. What is the memory location pointed by the EPB4? So we need to search for this 004010FD. So let's go to expression 004010FD. He said what? 10FD. 10FD is here. He said 18. Pointed to this one. Before your 10 is compared to 0, the 0 is here. What is the memory location pointed by EPB4? So is this one. And then we need to do, I forgot already. This one. Right click on it once again. Follow dump. Why you have to follow turn, then you create address EPB4. So this is the address, if I'm not mistaken, or I'm not doing the line is it will be 00 C84 750 if I'm not typing here. So it's this line. Can we copy? copy line. Let's see if we copy line. No, it's not that one. So before you return compared to 0, what is the memory location pointed by EPv4? FD. FD is this one. So we assume this one. Before you return is compared to 0. So it's this 18, we talked about it before. EPB 18 0. So maybe we follow this one. I think I can't tell you 100% why, but follow dump EPB4 same value. No, damn it, that's the value. Copy line, it's this EPv4, that's the value, that's a PG, don't know what is this. Is this first one? I think that one, yeah. Is this one the first one? That's EPv4. So it should be this one, not that one. Oh, again is not 0019 FBD4. Huh. I did solve this one. What the hell today is not solving? Before you which it said 10 FD 10 FD 10 FD 10 FD is this one. He said before I think in my mistake I went down, you should go up. He said before you turn, before compared to 0, we're looking for EP4, so it should be this one. Follow in dump address, but it's still the same. It's a 0019 FBD4 or 0C847550. What is the memory location pointed to before? Are we supposed to follow what? The value? 0019 FB D4. This was wrong. Now I'm got confused. Before you turn is compared to what is the memory location pointed by EPv4? Move down. But this is the middle shift. Why sometimes we complicate things? 0040 10. You tell me this is the memory, just look that one. No, it can't be. I solved this last time. What the hell, now I'm confused about it. Follow in dump address before. I thought it's this one. Because this one, when we follow in dump, you see, that's what we did there. So don't tell me we modify this. That's why the, you know what, I think so. Maybe we modify this. We messed up the memory because we do the patching. Let's open it again. Let me open MV detection again. Yeah, let me open it again because now it's yeah, F9, you can run it, it's fine. And then let me search for the, for again 004010 FD. So go to expression 004010 FD 4010 FD 4010 FD is that one. So before the EP18 return compared to 0, we have this. Following them, oh, it's still the same things. Address IPv4. So now we have this is IP4 00 00. It's this one. This one you can see it's 0019 FF7C. No, now I'm lost. Following dump address. It can't be. I'm just getting the, before you return compromise to 0 compared to 0. Damn it, where is the return now? Now it becoming this is the memory, the EP18. We know this memory compared to 0 and we follow it in dump before, and then we come here and we find it. It's a 0019F. Press F8 to through the code until you reach the memory location. FF08. I'm not really sure what's going on here. I think I'm doing something wrong. I forgot about it. But so if you go, let me follow what he's doing here. I think it's better to. So we can press F9, just run. I think VM detection. Press F9. Okay. Do enter the value and press OK. This will take you to the memory address 10E0. Press F2 to set a breakpoint at this memory location. Then press F9 execution. Right now we are in the memory location. Okay, search for, go to the expression 0040 10E0 10E0. Press F2 to do the break, yeah, the breakpoint there, E0. and that's maybe I didn't do the breakpoint, that's why. Then press F9 to hold the execution. Okay, and then into location FD. So we jump to FD. Oh, that's the location. We press F8 time to location, and that's the part when they said right click, follow in dump address EP8, and that's why he said it's in 00. That's the value 19. So if we do now follow in dump, now it should work. EP4. Now the address EP4 should be 0019 FF1C. Now it should work, so we need to follow all the steps. So 0019 FF1C. So this is the address. Oh, thanks God. So you need to follow the damn steps. I thought we can jump. I'm not sure why we should yeah, really interesting this part. So you need to follow. So this is the part, right click, jump, following dump, you select that one, then you find the answer here. Okay, that's interesting. The next one, Paka. Of course, this is like a technique we may do, like code technique, like encoding, encryption, obfuscation. This is some tool we can use, guys. You can. Oh, this is just a quick question. This one. You can put in chef. That's the straight answer. This one, so you can read about it. And then the next one is right click. Now we're going to undefined unpacking, so we need to go to this. Remember this one, there's in room. So Paka, right click and say open with easy. Okay, the if can identify the user packet will display its best guess under this section. Okay, Microsoft Linker 14.6 Visual Studio. Okay, you can also click in the entropy button. Where is the entropy button? You can also click in the entropy. No, I don't see the damn entropy. It means I'm tired. Enter point export. Where is the entropy? I can't see it. Entropy. You can also click entropy button and on the right side of the screen. Entropy. Yeah. Okay. And you see it's packed. So you have there. Section is packed. And you can see it has been determined that section 1 is packed, section 2 not packed. Entropy jam, the level of disorder, and a sentence impact malware tend to have high entropy due to the randomness of the packing process. Okay, so we can say now close this. And then he said from this double click on studio icon, PCP Studio, that's another tool we can use. Open Paka, open file, let's go to Paka. In the list of items on the left panel window, click on the section self-modifying. Section self-modifying, yeah, this one. Username standard p file .x. Can we open this? I don't know, it's just okay. That's the information. but in the output table we can see that the section name have been changed. The string UPX0 are one of those identified pieces. Yeah, we can have this EPS, EPF1, EPS2. Okay, that's cool. Automatic unpacking, this website or something. This guys, I'm tired. You can read about it, I'm sorry. Now he said to us, we go to our friend, this one, the debugger, unpacking, okay. Let's go to expression. The value they want us to go is a 04172D4. Why is doing that? Go there, 00. Press OK. You will now be taken to memory location. This memory location before the enter provision part of the program. Press F2. Let's press F2. No, let's press F2. Then press F9. It become there. No, mine is no. There's something is not right here. F9 twice. Okay, twice. To move execution to this location. Okay, D4. Finally, press fast to jump to the memory location. What is? I always like to know what's the shortcut. Step into. Okay. This location is starting location of this legitimate program that the pack goes to once it's fully unpacked. Okay. By now you'll be curious about the memory location and the relevance to what we are doing. When using this UPX pack and malware is executed and the execution location reaches D4, so D4 is at the top, it indicates that the legitimate part of the program has already been successfully unpacked and now copied in the memory. It's a bit complicated in this room. I think you need more time about it. Have different approach when unpacking legitimate. Okay, to start now we need to dump with this Skylar plugin, Skylar, and then the dump process. And then we all use this to dump. Okay, once open, click dump button. Okay, dump button. Save there. We save it, and then what's that? Okay, we dump it. If we can run, if we want to run it, pack a dump, it will give us an error because we didn't finish our work. We're going back to where? To Skylar, our friend Skylar. Click IT auto search. He said press no, and then press OK. At this point, the project value rate to IAT. We can now click get import, get imports, get import, and then we have this with some errors. Now this one you can will find invalid entries with X. You can get cut chunk. You can right click, cut, right click, and and then click fix dump, and select previously the file we did, that one, open, and then we have a new file with this extension fix dump. So if we go back and you have this file and it says it work, and we can test it with run it with easy ID, so it's 100%, so it's fine. And then with the malware impact you can now continue investigating the malware. However, don't fool into thinking that impact malware is easy. I can see it's complicated. Let's answer the question, guys. I'm a bit confused myself. According to detectives, what is version of Microsoft Link? It's 14.6. For 14.16. And then according to PS Studio, where is it? PS Studio, what is the entropy of UPX2 section? UPX2 section. Entropy is this line. So it's 2006. 06. And done, guys, done with the room. I think, guys, what we can say, I tell you, I'm sorry, I'm not 100% I can get, but things get complicated with malware. I think the best course is the TCM's security. I still didn't start it. I start and stop, but it's too many things in this room. I hope I was able to explain some stuff. Sorry if I'm not clear. Please, guys, help the channel by subscribing, liking, and thank you very much. Have a good day.